Greetings to all the learners. Welcome to this session of Bridge Course on Physics. My name is Suraj Mashilkar, working as an assistant professor at All India Sri Shivaji Memorial Society's College of Hotel Management and Catering Technology, Pune. In this session, we will discuss the topic on SI units in physics. Let's have a look at the objectives of this session. The objectives are, first, to understand the meaning of SI units. Second, to enlist 7 fundamental units and their SI units under the same. Third is to enlist 2 supplementary units in the SI units. Fourth and the last is to understand the meaning of different fundamental units and their uses. Let us recall the previous session, that is units of measurement, in which we have discussed about various systems of units like CGS system of unit, which is based on centimeter, gram and seconds, MKS system of units based on meters, kilograms and seconds, whereas FPS system of units which is based on foot, pound and seconds. All these above systems of units were the baseline units that in some means contributed towards developing a universal system of unit, that is the International System of Units, also referred to as the metric system. The system of units is commonly abbreviated as SI, which comes from the origin French name, that is Système International d'Unit. So, to begin with, let me introduce you to the International System of Units. Think of them as the special tools we use to measure stuff in science. Imagine you're trying to describe how long something is, like a piece of string or a big building. How would you do it? That's where the SI units come in handy. They give us a standard way to measure things like length, weight, time and many more things. These units are like the language scientists all around the world speak. So, whether you are in Japan, Brazil or anywhere else, everyone understands the measurement because they use the same SI units. Now, why are they so important? Well, imagine if everyone used different units to measure things, it would be chaos. Scientists wouldn't be able to understand each other's work, and we would never make progress in understanding the world around us. With SI units, we can measure everything from how long a piece of hair is to how far away a star is in the sky. They are like our trusty toolkits for exploring the mysteries of the universe. In our session, we will take a closer look at the main SI unit and what they mean. We will learn how to measure things like length, weight, time and more using these units. So, let me define the SI units for you. SI units, short for the International System of Units, are the standardized set of fundamental units used in science, particularly in physics, to measure various physical quantities. These units provide a universal language for scientists and around the world to communicate measurements accurately and precisely. So in simple terms, SI units are like the rulers, scales and clocks scientists use to measure things in the universe, whether it's the length of a room, the weight of an object or the time it takes for something to happen. SI units give us a consistent way to quantify and understand our world. Now, how do you think was the SI unit developed, or when was it implemented? Let me take back to you to the late 18th century. During the French Revolution, a time of a great change and upheaval. In the midst of the social and political transformation, there arose a need for standardized measurements, especially in scientific and commercial endeavors. In response to this need, the French Academy of Science proposed the adoption of a uniform system of measurement, which led to the creation of the metric system in 1799. This system introduced units such as the meter for length, the kilogram for mass, the seconds for time, laying the foundation for the modern SI unit. Over the years, as scientific knowledge expanded and technology advanced, the metric system underwent several revisions and refinements. In 1960, the 11th General Conference on Weight and Measures established the International System of Unit, building upon the metric system while incorporating new advances in metrology, which is the science of measurements. The SI system was officially adopted by the international scientific community as the standard for measurement, providing a coherent and consistent framework for expressing physical quantities across different scientific disciplines. Since then, the SI units have continued to evolve with periodic updates and refinements to reflect the latest advancements, science and technology. Today, the SI units are widely recognized and used by scientists, engineers and researchers worldwide, playing a crucial role in advancing our understanding of the universe and shaping the progress of human civilization. This system of unit consists of 7 fundamental units or quantities and 2 supplementary units or quantities. Now let us have a look at these 7 fundamental quantities with their SI units. Now you can see a table in front of you that talks about the fundamental quantities and the SI units, in which there is mass denoted by a symbol with small m, has an SI unit of kilograms, that is symbolized by kg, whereas the length with a small l has an SI unit of meter, which is symbolized by m, whereas time with a t has an SI unit of seconds, which is symbolized by s, and then there is something called as current, which has a symbol of capital I, and an ampere is the SI unit for the same, denoted by a symbol of capital A. Then there's something called as temperature, with a capital T as the symbol, has an SI unit which is Kelvin with a capital K. Then we have something called as amount of substance, that is denoted by small n, has an SI unit of mole, denoted by MOL as the alphabets of symbol, and then we have something called as luminous intensity, which is denoted by candela as a SI unit, having a symbol of LV for the luminous intensity and CD for the candelas. These are the 7 fundamental quantities with the SI units. Apart from those, there are 2 supplementary quantities with an SI units, that is plane angle, which is said to be as the radian, has a symbol of R, whereas solid angle with a unit of steradians with SR as the symbol. Now let us see these 7 fundamental quantities and their units in details and what are their definitions. The first is the length, denoted as meter with m. Length is the measurement of distance between 2 points. It is a fundamental to geometry and is used extensively in various fields such as physics, engineering, and construction. The next SI unit or the fundamental unit is mass, which is having a kilogram as the SI unit with kgs. Mass is a measure of the amount of matter in an object. It is distinct for weight, which is the force exerted on an object due to the gravity of the earth. The kilogram is defined as the mass of the international prototype of the kilogram, a platinum iridium cylinder kept at the International Bureau of Weight and Measures. The next is the time, denoted by second with a symbol S. Time is a fundamental concept that measures the progression of events. It is often considered the fourth dimension and is crucial in fields such as physics, astronomy, and everyday life. The second is defined based on the duration of 9, 192, 631, 770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium 133 atoms. The fourth one is the electric current, which is denoted as ampere or has an SI unit of ampere with a symbol A. Electric current is the flow of electric charge through a conductor. It is fundamental to understanding electricity and magnetism and plays a crucial role in electronics and electrical engineering. The ampere is defined as the constant current that is, if maintained in two straight parallel conductors of infinity length or infinite length of negligible circular cross section and placed 1 meter apart in a vacuum, would produce between these conductor a force equal to 2 multiplied by 10 upon minus 7 newtons per meter of the length. Thermodynamic temperature, that is temperature, which is denoted as kelvins. Temperature measures the intensity of the heat, that is, or cold of a substance. It is used in thermodynamics, physics, and chemistry. The Kelvin scale is an absolute temperature scale where 0 K represents, that is, absolute zero, the theoretical lowest possible temperature where molecular motions ceases. The next quantity is the amount of substance, which is denoted by the SI unit called mole, with MOL as its symbol. The amount of substance measures the number of entities, that is, the atoms, molecules, ions, etc., in a sample. It is a fundamental in chemistry where it is used to quantify chemical reactions and express the amount of the substance. The last one is the luminous intensity. Candela with a CD has luminous intensity measures the amount of light emitted in a particular direction. It is a fundamental in photometry and is used to quantify the brightness of light source. The candela is defined as the luminous intensity in a given direction of source that emits monochromatic radiations of frequency. Now, what are the supplementary quantities and what are their SI units? The first one, that is the plane angle. Radians, that is RAD, is the unit for the same, is a measure of the amount of rotation between two lines that meet at a common point, also known as the vertex. 1 radian is defined as the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. Radian is a dimensionless, meaning it does not have any units associated with it. Radians are commonly used in mathematical and scientific contests, especially in trigonometry, calculus, and physics, due to their convenient relationship with the properties of circle and periodic phenomena. Next supplementary unit or quantity is solid angle, denoted by a steradians. Solid angle is a measure of the amount of spatial coverage or extent suspended by a surface or a three-dimensional object as viewed from a point, One steradian is the solid angle suspended by a portion of sphere's surface with an area equal to the square of the sphere radius located at the sphere's center. Like radians, steradians are dimensionless. They are used in fields such as optics, astronomy, and radiometry to quantify the amount of light or radiations emitted, received, or intercepted by a surface or detector in three-dimensional space. While not considered fundamental like the 7 base quantities, plane angles and solid angles are crucial supplementary quantities that help describe and quantify spatial and angular measurements in various scientific and engineering disciplines. With this, we come to an end of the session on International System of Units, that is the SI units. Let us have a small recap of the session. Now, what we have done here is, in this session, we have covered something called as defining the SI unit, where the SI unit is just a short form of International System of Units. These are certain standardized set of fundamental units used in science, particularly in physics, to measure various physical quantities. These units provide a universal language of scientists around the world to communicate measurements accurately and precisely. What are the 7 fundamental units is one of the points that we have covered today. Now, what we have done next in this particular session is the 7 fundamental quantities and their SI units, and what are the 2 supplementary quantities and what are their SI units. The 7 fundamental quantities are mass, that has kilogram, length with meters, time with seconds, currents with ampere, temperature with Kelvin, amount of substance with mole, luminous intensity with candela, whereas plane angle and solid angles are the supplementary units with radian and steradians. In conclusion, the international system or the SI units is like a universal language for measuring things. It helps scientists, engineers, and others all over the world talk about measurement in the same way. With SI units, everyone agrees on how long a meter is, how heavy a kilogram is, and how fast a second is. This system makes sure that the measurements are accurate and consistent no matter where you are. It's like having a rule book that everyone follows, which helps in science, industry, and everyday life. By sticking to the SI units, we can work together better, understand the world around us more clearly, and create new innovations and inventions and discoveries. It's a tool that helps us make sense of the complete universe and improve our life. Thank you so much.